welcome in my lab. This is the second video I'm making to present you the setup that is actually running in this lab. So here we are in France, and I'm going to present you the general surrounding and the details of the cell. The big difference we have with the previous experiment is that we are pulling vacuum permanently on the cells by this capillary, and that goes right to a vacuum pump that is hidden in this box. So we are measuring continuously the level of vacuum that is delivered by the pump just after the plumbing. The manifold is splitting all the way between the gas injection, each cell separately. The gas injection is here now just to show you how the configuration is when the gas is injected, otherwise it's just taken off. On the cells, so there is much more thermocouple this time than the last time. So we have 3 thermocouples inside and 3 on the outside. The outside are located on the surface of the tube. So what I've done, which is very different from what you used to see, is I took a disc of sticky carbon tape for scanning electron microscope. The disc is cut in 2, so it's like a 2 half moon, and after it's warped around the end tip of the thermocouple, and then it's cut on the outside just to make like a small coating of carbon on the outside, and then it's stuck on the surface. Because it's sticking, it's stuck on the surface of the borosilicate tube. At each end of the mica, we have end pieces made of maple, very similar to what Celani has been presenting to us. The 3 thermocouples are fixed on the outside, and the thermocouple on the inside are located on the surface, here and here, and on the mica. Yes, here. So we can see it's going from this place to here. So the mica is taking the highest temperature inside the cell. Here is the second one. So the orientation is the same for both. I mean the orientation axially and radially. So there is, I forgot to mention, 2 pressure gauges on each side when we're doing the loading. And on the back of the table here we have a Geiger counter. So it's able to log but not currently logging. And underneath the paper sheet we have the acquisition system and the power supplies connected to the computer, which computer broadcasts you the data live. On the other side we have the second acquisition system. Oh yeah, the pressure gauge controller, the vacuum gauge controller, sorry. And the other side of the power supply and acquisition system. So this is located underneath a paper sheet because of the flowing air that are coming from the power supplies and the different equipment. It's a free air configuration, which is very different from what HAG is doing in the States. So this room is thermoregulated to 20 degrees Celsius. The configuration is that this room here is acting as heat capacitor, the same way this room is. Here we have the wall that is giving on the outside and the south side of the building, so it's acting at the heat source when the heat is coming in. And the corridor is also acting as a heat source because there's no outlet. Here you have an example of an outlet. In the room here you don't have any other outlet, so it's acting as a heat source. The room is at the same time with a heater and a cooler. So the heater is set at 20 degrees roughly. It's not very precise, but it's giving some heat back. And behind this sheet of paper, let me take some distance. Here we have outlet for cooling. It's behind, so here it's the ceiling is completely flat, just some lights above, and behind the sheet we have the outlet. So the outlets, the cooling is targeted to go down instead of going to the cells, so that reduces a lot the convection effect and the impact on the measurements. One last thing I forgot to mention is that the control system of the cooling is located in the between of the two cells. If you want to comment, leave message, I don't know, send us some improvements that can be done in a relatively fast way, let us know. Thank you.